Hello and welcome back. Let's say you are in a standard calculus 1 exam. If you are asked to differentiate x to the power of x, you are taught exactly one way to do it. And this one way to do it is a method that breaks the definition of a function that is somehow miraculously gives the exact same answer. So let's see if you can spot why this works or if it's just a coincidence. It's something for us to know. Okay, so let's say a student, let's say name, what was there? Okay, sorry. Let's say you are a student A. Let's say you are a student A, and student A is trying to solve now the question. So Mr. Student A is gonna do looking at x power x and starts thinking it's a power function like x power 2 or x power 3. So he will start solving it as an x power a method, which won't work for these or with it. Okay, so they apply the power rule, bring the exponent down and subtracting by 1. So let's try to do it, which the rule says that d by dx of x power n is gonna be n x, okay, n of times x n minus n power n minus 1. Okay, so the attempt or the action that this student A is gonna do that he will do x times x power x minus 1, letting him in a state where it's gonna be x times x minus 1. If we did that again, if we calculated this is gonna be after the differentiation. If we calculated this, doing this is gonna be returning back, multiplying these two is gonna be returning back to x power x. A differentiation of x power x is not gonna return back to its normal value again. We're not gonna return to its value again, so it's not the differentiation. So there must be a rule for it. So it's because x is not a constant exponent, that's why we cannot solve it using this method. So let's try with student B. Student B is going to do the following. He looks at x power x and thinks it's an exponential function like 2 power x or e power x or something. So he applies the exponential rule. The exponential rule says, that d power by dx of a power x is going to become a power x ln of a. So the attempt result is gonna become x power x ln of x. Then that is also wrong, like this one. Both are wrong. The base is not a constant, yeah, neither the exponential. So what if we used both of these? Let's say we tried to use both of these. When we use both of these, actually the answer comes out. So what if we tried to combine both of these, combine number 1 and combine number 2? The result of these two is going to become from 1 plus 2 is going to become x squared plus x power x here, this one, and x power x ln of x. Let's take x power x as a common factor, so x power x of times 1 plus ln of x, and yeah, wow, voila, this is the answer. So let's check again as the actual correct answer using logarithmic differentiation. So let's check over it. So let's say y is gonna was x power x, then it became ln of x, ln y, then we're gonna do len here and len there. Okay, we're gonna do len on both sides. It's a method for solving questions in order to make the exponential down, like len of something gets the exponential, like let's say y power x is when len y power x is x len y. Okay, so that's something. So returning back to our state, so it's gonna become len y equal x len x. So by that it becomes y dash, or like dy by dx of over y equal 1 len x plus x 1 over x. Okay, we did the differentiation on both sides for here and here. Okay, then if we did factorize that, let's leave the y bar or the y dash here on this side, so let's throw this y the other side. So y bar is equal to y 1 len x plus 1 equal to x power x 1 plus len of x. By that, this is identical, this one is identical to this answer. So by that we have proved that the sum of these both methods has got the answer. Why? Was that luck or was that math? It's not magic. It's a multivariable calculus. It's a part of calculus called the multivariable calculus. It's called multivariable calculus, where this we replace the base of with like u and the exponent by v. So it's u power v or v power u, like 2 power 3 and then the u power v. Okay, so these u and v comes for variables, since they're not constants like 2 power 3 or something. That's why we use these. So to solve both u and v, we depend on x. We use the multivariable chain rule, and the chain rule is defined as following. It is d of f by dx equal to df by du times du by dx plus, it's not d here, it's partial. Okay, it's partial df by partial u times du by dx partial f by partial v by dx dv by dx dv by dx. Sorry, this question always gets me wrong. So look at the first term, d of f, partial f by partial u. It means that the derivative with respect to the base is treating the exponent as constant. Yeah, this exactly is the power rule. Look at the second term, which is the partial f by partial v. It means that the derivative with respect to the exponent treating the base as constant. So with the conclusion, so the method wasn't actually illegal or something, it was just total derivative in disguise. The student A has found a change due to the base, and student A was due to the base, and student B was due to the B was due to the power itself, or the exponent. So if we added these both together, we get the actual answer what we were looking for, and that was the thing. And there is always also visualization to these sort of problems, like x power x, which has actually an interesting visualization to this, but this is beyond the question or beyond the explanation. So I will leave it there, and will always write you thank you for watching, and please subscribe. Thank you very much.